What's up, everyone? Back with more picoCTF 2022 Capture the Flag challenges. Today we are looking at the Keygenme reverse engineering challenge. The description is pretty short. It simply says, can you get the flag? Reverse engineer this binary. And then it gives us a link to download. Right click, copy link. And then I like to make a new working directory with the name of the challenge. So make dir Keygenme, cd into that directory, and then download the file with wget lstech.la Keygenme. Let's make it executable so we can actually run it. Enter your license key. Please sub. That key is invalid. Okay, can we cheese it with the ltrace to look at the library calls it's making? Maybe there's a string compare. No, what about strace? Okay, a giant wall of text. This is just setting up the virtual address space. But down here at the bottom, we see the write call. Enter your license key. And then read. It's waiting for our input. Nothing. I was just checking to see if there's a string compare or anything similar that would just print out the flag. Let's look at the strings of this binary. Pipe that into less because the output is going to be pretty massive. Okay, lib64. That's the C standard library. Or rather, libc.so.6. That's the C standard library. This is probably related. We see a call to sprintf, call to puts. Standard in is read. Formatted get string, string length. Okay, this is interesting. We see the start of a flag, picoCTF, and then an H. Bring yo own. So if we start piecing this together, picoCTF, bring your own something. And then the rest of the flag is cut off. We don't see the closing curly brace or anything. We see more, strings that we saw earlier. Enter your license key. That key's valid. That key's invalid. But nothing else here. Okay. ls. Let's open this up in Ghidra. Ampersand to run that in the background, so it gives me back my command prompt. Ghidra takes a little bit to load up, so jump cut. All right, Ghidra finally loaded. Ghidra is a project-based reverse engineering, disassembly, and decompilation tool, but you need a project. And you can see I have no active project, so go here, File, New Project, Non-shared, next. All right, that's the directory I want. Just call this Keygenme. Finish. Okay, now I have this project folder, and here's my tool chest. If I hover over it, it shows that this is the code browser. I have a debugger and version tracking. So I played around with the Ghidra debugger a little bit early on, and I just could not get it to work, and I did not really try that hard. So we are going to use the code browser. Click on that. You get a cool dragon pop-up. Nice. So the code browser is loaded, but you see there's no program. So go to File, Import File, and then we want our keygen.me binary. It imports it. It correctly identifies that this is an ELF file. Oh, one thing I forgot. Back here in the command prompt, we can run file and then keygenme, and we see stripped. Now that's important. Stripped means that it no longer has the debugging information. So if I try to run this in GDB, right here it pops up trying to read symbols from keygenme ... No debugging symbols found. Okay, what's the big deal? There's no debugging symbols, but can't we still debug the program? Technically, yes, but if I try to disassemble the main function, I get an error. No symbol table loaded. Okay, what if I just say disassemble? Nothing, no frame selected. Use the file command. All right, file, and then keygenme.py, or just keygenme. So it rereads the file and no debugging symbols found. So this is right now just too hard to debug. GDB doesn't understand it. It gets confused. There's no debugging info. There's no symbols. It does not know what main is. I can type disassemble, and then tab twice, and it auto completes. So these are the functions it can see, right? These are the things that it has access to, but there's no main. There's no main function anywhere. So for right now, this is not very helpful. Let's go back to our Ghidra tab. Elf. Okay, cool, hit OK. We get this neat little animation of a dragon eating some ones and zeros. Keygenme has not been analyzed. Would you like to analyze it now? Yes, please. So that's going to analyze the ASCII strings, the calling convention that it uses, and so on and so forth. You can uncheck these as you want, but I'm just going to leave it as the default. Click Analyze. Here's some more info about our binary. Hit OK. And you can see down here in the bottom right that it's still analyzing. It's taking a little bit. All right, Ghidra is done analyzing the program, and there's no main function, but we have entry. So I can click on that, double click, and it brings me here. So this is the disassembly, this middle panel. This is all the assembly instructions that we could not see in GDB. And here over on the right, let me expand this. This is the decompiler window, right? So this tries its best to recreate the source code, in this case, C. libc start main. Let me just click on this first function. See where that takes us. Okay, so I like Ghidra. It's free, it's open source, and it has a built-in decompiler. However, it doesn't always pick the best variable names. So we see 4 variables declared here: a character, a long, some type of buffer, another long, and then this looks familiar, right? Printf. Oops, didn't mean to double click that. Line 11, printf, enter your license key, formatted get string, so it reads in our input and it stores it here. So I don't like local _ 38. That's not very clear what that means. So I can right click and either click here, rename variable, or just press L. So let me rename that. Instead of local 38, let's name it something more familiar, buff. And you see that it renames it here and here as well. Line 13, C var1 equals the output of this. And if that is equal to 0, the key is invalid. Otherwise, print the key's valid. So this is probably the return value. Hit L to change it. I'm just going to call it retval. And I'm going to go through and clean up the rest of these variables so they make a little bit more sense. Cool, so I've renamed all the variables and the function at the top. I've just called this main. It declares 4 variables, and then the return value, if it equals 0, that's invalid. Otherwise, it prints valid. So what is this function? What is fun 00101.209? That takes in our buffer, that's our user input, as an argument. Double click on it. Let me expand this. Okay, let me name this something better, like check key. So we see a crap ton of variables being defined. All right, what is this data? Oh, cool. It goes away quickly, but you can see there, care, and then the open and closing bracket, there's a quote. That looks like our flag, but it's backwards, right? Reading it backwards, you can see picoCTF and the opening brace. You can see that over here as well in the disassembly output. So the next one, BR1NGY0. Okay, so this is our flag in reverse. I'm guessing because this is a little Indian. Anyone in the comments who knows better, please correct me. Why is our flag being printed in reverse? Cool. Let me open like a notepad or something so I can jot this down, and I'll be right back. Alright guys, so I went through one by one, highlighted these entries, and wrote in what we have so far of our flag. So we see this is Leet Speak, picoCTF, bring your own key. And then I have 8 question marks here because picoCTF at the end, like the beginning part of the key will be the same, and then it adds 8 random characters at the end to make your flag, your key, like unique. And this prevents you from being able to just copy paste and share flags from write-ups or copy paste share flags from across teams, right? Because this is a competition. It's just a way to force you to kind of go through and at least attempt to solve the challenge. So we have the main structure of our key, and we got that. Again, we haven't really reverse engineered anything. We just came into this function and we noticed these values, these strings being added to these different variables. So just like before, let me hit L to rename some of this. Instead of local 98, I'm just gonna call this flag piece 1, and so on and so forth for the rest of these. All right guys, back. Just as a reminder, you do not need to rename variables at all. I think it just makes it a little cleaner and easier to follow this logic. So on line 38, we see a string length of flag piece 1 is called. So let's call this length. The MD5 hash is computed and it's stored in like this buffer. Let's call it buff1. Same thing for flag piece 5, the very end. Let's call that buff2. Something equals 0, and we see 3 for loops. Let me quickly just call this I, call this J, because you can't reuse variable names. And this looks like an index. All right. Local 78, not sure what that is, some type of buffer. So I would assume this is doing some type of like obfuscation. And down here we see 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 variables being stored in some stack variable, some stack offset. And the last one is our flag piece 5. So if there's 9 of these and then we don't count the flag piece 5, there's really 8. So this is the 8 unique letters, the 8 unique strings that are added at the end to make our flag, whole. Right now I have it just question mark as placeholders. So we want to figure out what this is, right? Local 43, 62, and so on. All right, if the flag equals, or if the length of the flag, right, param1, that's a parameter up here. That's our key. I'll say user input key. All right, that's what we enter at the command line when it asks us enter the license key. So if that is equal to OX24, which we see here is 36, so our flag needs to be 36 characters in length. It does some for loop, and it checks every index of our flag against what's stored at this like stack variable. And if at any point they do not equal each other, it returns 0. And we saw earlier, if it returns 0, you need to go back one more. If it returns 0, then it prints that key is invalid. So we want it to return 1, right? And how does it return 1? If the flags are equal. So we need to debug this, and there's a few ways you can do it. Let me bring my GDB back up. So I can't disassemble main, right? There's no debugging symbols loaded. You could do it in Radare 2, that works fine, but using Radare 2 is very confusing for me. So instead of setting a breakpoint on main, because it can't find it, I'm going to set a breakpoint on a function it can find, such as this call to sprintf, or printf. Breakpoint 1, set at this address. We don't know what the base address will be, we just know the ending address. Before I do that, let me back up. We want to provide this as our argument, right? Maybe I don't have to back up. Maybe I can just copy this. Run. Okay, breakpoint 1 at printf. Enter your license key and Here, let me queue out of this. So vim, I don't know, fake key, fake flag. And let's paste in that. Now run GDB. Break at printf. Run. And as input, put in my fake flag. So it reads in my fake flag, and then it prints enter your license key. So now if I hit disassemble, I'm inside the printf function, right? If you're curious what this address is, what, you know, Y7FFFF9B, you can do info, process, map. And these are the different addresses of libc, right? The C standard library. libc, libdll, libthread. So that's where it's getting that, you know, base address for printf from. Hit enter. We see our stack address is down here. Clear that screen. So disassemble. So this is the assembly code for the printf function. Cool, but that's not really what we care about here. I want to exit this, so type finish. Now type layout assembly, and just like that, does any of this look familiar? We see the call to printf that asks us to input our string, and then we see an fgets call down here. If my mouse will work. Right? And then we see put string and put string. What does this look like? It looks just like our code browser, right? If I go back to the main function, we see a call to printf, call to get string, and you stop doing that. So we're in this function. We're in the main function. And then here's our call to that like key check, right? So I'm going to set a breakpoint there. Add a star, because it's important. Hit C to continue. And now we're here. Type S to step into that function call. Cannot find bounds. Is it SI? There we go. SI, step instruction. So here's the strings from earlier, right? This was a picoCTF backwards. I wonder if I can print that out. Examine a string, all that. Nah, that doesn't work. If anyone knows GDB better than I do, is there a way we can print this out and have it as a string? Because before it was like the backwards picoCTF thing. So I'm using my mouse wheel and I'm scrolling down, and we see this. We see these variables, these values being pushed onto the stack. This is the same as what was over here in our check key function is what I named it. So these are the 8 unique characters at the end. They're all being pushed here. So I want to set a breakpoint and let this code execute. So all this is pushed on the stack, and then all I have to do is print the stack address. So let me set a breakpoint. Where's a good call? Where's a good stopping point? I'm going to do it here at this compare call to check that we've entered a 36 length string, enter, C to continue. You see the little b is now a capital B, so we're at this line, and I want to print this stack address, right? So we know this very last one was the closing brace. Let's just print this out. Let's see what happens. Examine a string. In GDB, you need to put a $sign to specify a register. Okay, that's a bunch of crap. Let's try this one above it. There, that's the closing brace. I'm not sure what this is. Maybe some type of terminator, I don't know. But this is the closing brace. So this is the next unique character, and so on and so forth. But the stack is a first in, last out. So the first thing that gets pushed on, like these just keep getting added on top of each other like a stack of plates, stack of books. So the first are, the first book's on the bottom and the last one is on top. So everything is in reverse. Programming and debugging can be very confusing at the beginning because a lot of things are just straight up backwards. So if I print this first one, this top one, see what happens. It prints everything else, right? And then like some garbage that I guess was on the stack beforehand, and we see our flag, picoCTF, bring your own key, and then this is my unique string, right? My unique characters, right? So I can replace this with that, or I can just grab it here, copy it, and then submit it. So that's how I solved this challenge, guys. There is a way to do it with a different debugger. I'm just a big fan of GDB. Again, in order to get this graphical menu, layout, ASM, layout assembly. So that's how I did it, guys. I'm a reverse engineering noob. So if anything in this video made you cringe, it made you want to bawl your eyes out because of how bad I'm doing, let me know in the comments below. Let me know if you found a better way to do this. As always, take it easy and see you guys in the next video.